Awesome. So I am Brian Douglas, as our host has mentioned, and I'm going to talk about serverless side rendering and React. There's a lot of confused faces out there. You guys, who's ever heard of server-side rendering? Who's ever heard of React? Cool. And then who's heard of serverless as a term? Anybody using like serverless Lambda functions or anything like that? Okay, some of us. Awesome. So I'm going to jump right in because I have a lot to cover. This is a lot. Kind of like more of like talking about how we got here and some ways that we can actually do this. But I just want to come up front and say, at the beginning of the talk, and say serverless. When I say serverless, I don't mean no servers. There are really servers somewhere. You just don't have to worry about them. The same way my phone and my laptop uses wireless internet, but there's a wire somewhere. It's just not connected. So if you think of it that way, then we'll get through this. My slides are all, I put on the meetup, my slides are all like goober.netlify.com. Netlify, we host stuff, so I just throw my slides up there so that way people can find them. I also threw it on meetup, so if you were there in the comments, you might have saw that. Cool. So anybody use Webpack? I know we have like, now we have Create React apps, so it kind of extracts a lot of stuff. So if anybody remembers the days, like if you used React more than a year ago, then you remember how hard it was to get stuff working, and Webpack was part of that problem. Now Webpack's easier, but also React's easier as well. So what Webpack, well, actually, does anybody know what Webpack does? Like we know it exists, but so Webpack really what it takes is your bundle of all your JavaScript, your React, and it bundles into static assets. So I'm using Webpack's homepage because I think this actually really kind of tells us what it actually does. It takes a bunch of stuff and then it makes in these nice little bundles for you, so you can get like code splitting and you get static assets like sort of like magic. It's not really that much magic. Once you look in the Webpack, you just find it's a bunch of key value store logic. So, and I mentioned as well, my sites are hosted on Netlify, but I also work at Netlify. We are a continuous delivery platform for hosting stuff like that static stuff that comes from Webpack. We handle the continuous delivery of that. And I bring that up because Netlify, again, we deploy static assets. And the word static is kind of a dirty word. Whenever people like think of static, like, oh, cool, you do like brochure sites and like index.htmls, and pretty cool. But we actually do more than static. And because of that reason, that confusion with the word static, we came up with a new term called Jamstack, which is JavaScript APIs and markup. So you can take all the modern web development practices like Webpack and all that other stuff, including React, and we just created this whole new term called Jamstack for that reason. But again, going back to what Jamstack is and what Webpack does, I'm talking about when you run npm run build, you get that static output, and also Webpack-p as well. So that's how you get that minified code and that bundled, the bundled.js. Cool. And before I jump into that whole server-side rendering stuff, I just wanted to make this explanation too as well. So there's like this difference between like monoliths. You guys know what a monolith is? Is that the term that we still use nowadays? So back in the day, my mom bought this once and she made that mistake once. I'm not a big fan of having peanut butter and jelly in the same jar. I'm a bigger fan of separating those, mainly because it's slower, it's also costly, and it's vulnerable to attacks. So like if I just want peanut butter, I cannot just get peanut butter. And if I just want jam or jelly, I can't get one at a time unless I have a tiny spoon. Cool. So this is the jam architecture. Again, just kind of hammer this down because we're going to talk about this more in a sec. But that's easily, it's just separating your front end and your back end. Like separate repos, separate projects, separate concerns. And it really models what we used to do like 20 years ago, 25 years ago when we used to do the web, when we had like a client and we had a server separated. It's the same thing. And thanks to things like Webpack and Gulp and Browserify and Rollup and all these other things, you can get that minified bundled output, which is great. So I'm going to talk about server-side rendering because before I can talk about serverless side rendering, I got to talk about where we are today. So server-side rendering, I'm going to go through some myths. A lot of people will reach for server-side rendering first because of these three things. And I just want to explain that these aren't usually the things I would reach for server-side rendering for. And I'll start with code reuse. Does anybody do server-side rendering today? Isomorphic JavaScript. It's awesome because you can have your client and your server in the same file structure. But the problem with that is, anybody came from React and did Angular before? How much of that Angular code did you reuse in your React app? Probably not too much, right? So it's more of a myth about whole code reuse, because if you want to, like, frameworks are going to evolve. We're probably not going to use React in 10 years. Maybe it's going to be called something like Reactatron or something, something much better made by Microsoft. And so knowing that, we're probably not going to do some of these, like, we've got this down the street. We've got like Pinterest and Airbnb that have been around for, it seems like forever, but it's not really that long. But they're like running through Python apps and stuff like that, doing some isomorphic rendered stuff to make that work. And they've gone through the pain of starting on the Rails train or the Django train and now have to switch to something new. So they're figuring out this stuff. So I just want to mention, like, the whole idea of code reuse is great for teams. It's not great for forward thinking. So if you want to change your front end. And I personally had this problem where we had an Angular app and I switched it to React, and I didn't have tons of issues to migrate the code base to like a new React code base because my API was still the same. So I was just rendering JSON, and I consumed that in React. So that's all I have to say about code reuse. It's not really that I don't have a big hammer to like convince you not to use server-side rendering based on that alone. But let's talk about SEO. So I know SEO is a big deal for a lot of companies that want to make money. I know not all companies want to make money. I don't know what you're doing, but if you're hiring, I'm sure you pay high salaries, but I'm not sure how that works. So SEO. So server-side rendering is great. React got it really good. There's some other frameworks that do this really good as well. So in React, you could do like a component that will mount, do all of this stuff. Everybody's done this before. It seems like a lot of people rose hands. And then you can render the string, send that to the server, send it back, and get like this full HTML page, which is great because SEO, right? The other thing is, in addition to SEO, like people liking that full HTML because then you can actually read this. So this is like the view source of Airbnb.com. And the problem is it's actually not that readable because one, it's all minified. Two, I'm not really sure what's so important. I know you can't read that from the back, but there's a lot of bang importance. So I guess they're doing some sort of weird CS and JS or whatever it is, but obviously I can't rip off all this source code from Airbnb.com like I used to do like in college and high school. Those days are pretty much gone, so I think we just need to move on from that idea. So yes, you can view the source, but most likely you can't really do anything with it. So let's just talk about server-side rendering. So as of today, as of actually, 4 years ago, Chrome's been able to read JavaScript. So when I think SEO, I always think Chrome, Google. Sorry, not even Chrome. I did not mean to say Chrome, but I meant Google as a search platform. They're able to read that JavaScript, which is awesome, because this article is literally from 2015 to explain since 2011 that they've been able to do this. Sort of like this complaining, like, hey, we can read JavaScript. So as far as reading JavaScript and doing server-side rendering, you're not getting the benefit's not really there if you're worried about Google, because Google's web crawler can read JavaScript. So then the question is, what about Bing and friends? And then the real question is, what about them? Obviously they don't really matter. But really, the answer to that is really pre-rendering. Has everybody heard of Prerender.io, Prerender.cloud? There's some services that literally do what they say. They pre-render your output, and it is able to provide to the web crawlers exactly what your page needs. So for SEO purposes, this is a solved problem. I did self-promotion. I wrote a blog on my company blog about explaining how that works. And I won't read the blog for you, but this is a little image I built. So essentially, if someone goes to netlify.com or yoursite.com, or sorry, not if someone, if a web crawler goes to your site and they want to get some sort of output back to be able to read it, to be able to look through it and then throw it up in this Google search magic witchcraft, this is the process that happens. There's a bot that basically decides, the bot that lives on your robots.txt or txt or however you want to do this, it's just going to load the page normally if you're not a bot. And if you are a bot, it's going to give you a pre-rendered cache. So you can have a cache that's actually pre-rendered every morning, every night, every 2 hours, whatever you want to set in your headers. And then those bots can actually get updated content. So if you have a blog post that you want to show up in your results in Google or whatnot, that will happen for you. I mentioned Prerender.cloud is a cool service. It's literally server-side rendering for JavaScript apps, except it's not the complicated structure of having two routers and all that stuff on the front and the back end. It just is actually a service that you just pay for, and it works. Another plug, Prerendering as a feature. So Netlify, if you decide to deploy your site with Netlify, it's like literally a one-click, and we'll start caching your site. on. I think we do 24 hours, but if you pay us, we'll do it more frequently. And what's great about this is that it works with React elements. So if you want to do things like have Twitter cards or Facebook cards or whatever that render content dynamically based on the experience that that person has. So if you want to render dynamic content for people who are in Brazil and make that Portuguese, you can do that. And you can do that through pre-rendering and stuff like that. So caching those. There's a little more work because you're going to want to make sure you have different languages or the internationalization or whatever. But this is all possible without an actual running server in the background. One more myth, which is speed. So the idea, I see you're shaking your head. I don't know if this is a good or bad thing. So speed, I know when I first got in my Angular Rails app, we knew that we could get rid of that white page and get the time to first byte really much better. But I found out really quickly that that we did fix that using server-side rendering, but we didn't fix that just from server-side rendering. We fixed it doing other things. Anybody heard of Adi Osmani? He works on the Chrome team. He's like one of the developer advocates. He created this thing called the HNPWA. So it's Hacker News, all as progressive web apps. And what's cool about this is you can see like all these different best practices of people using different frameworks on the front-end side and getting Hacker News to work. So it's better than the 2D. Actually, he started the whole to-do MVC movement. So instead of doing that over and over again, he started this Hacker News thing instead, which is cool because I was able to side by this take existing apps and they do like a comparison of pre-rendering, or sorry, not pre-rendering, but server-side rendering versus non-server-side rendered apps and see what the speed looked like. So what I did is I used two existing and I built one of my own, which are Hacker News clones. I modeled it all using the same structure of the Hacker News PWA. So they're using the Firebase Hacker News endpoint. So there's like an actual API that you can hit to get the data, and then basically render the data, and that's about it. So they all pretty much look the same, aside from some styling. And this is as close as apples I could get in an afternoon that I tried doing this. And then I actually wrote a blog post about this as well. And then from those experiences, so I didn't explain, I did one server-side rendered PWA. And I want to slow down real quick. Does everybody know what PWA stands for? So progressive web apps. So if you don't know what it is, just Google PWA, you'll find it. But this is the idea of getting your time to first byte a lot quicker, making sure your site works on all scales of all. So if it's on a CDN and it works in like Africa or China or et cetera, et cetera. So you just want to make sure, and also on mobile speed. So if you have a 2G connection, how fast your site loads. So those best practices have some other caveats that go through. I ignored all those. My focus was just more time to first byte. And then I finally, at the end, I just did my version, which was just a progressive web app that was built on Create React App, which at the time I was writing the blog post, they released a version that out of the box, progressive web apps came out of the box for Create React App. So that's the exact app that I did, whatever version that was at that time. And to test the speeds, I used 3 different tools. So Lighthouse, Test My Site.io, which disclosure, Netlify, we run that. And then that link that's supposed to say performance.security.net. That's another thing to test like how fast your site is in Australia or India and stuff like that. So I'll have to fix that on the slides that I have deployed. And again, just mention, this is more details in this blog post that I cannot go through. So check that out because there's some caveats to some of these. I mentioned all the kind of gotchas as I went through this. And also, big warning, past performance is no guarantee for future results. So these are apps that I literally just found. So they could have been written better. They could have been written worse. Who cares? I just wanted an apples to apples comparison for this. So going first, I had to get my baseline, which is hackernews.com. I figured why not check Hacker News first to find out how fast Hacker News is. So on the top right, I've got testmysite.io. You can see that the time to first byte, I don't even know what Hacker News is. It's in a Rails app or it's something, some sort of framework. Who knows? It doesn't really matter for this case. So time to first byte's that. It looks like the full download to HTML, so that whole server-side rendering thing, receiving the HTML, that's what it is. It's like almost a full second. Really not a big deal. Like what's a second to friends? So what I did notice is that it's kind of slow to India and Australia, and that's not a fault on their server-side rendering. It's a fault on whoever they're hosting with. So not that too much to care about at the moment. But as far as performance, it got a 98 just out of the box. So as of today, so that's like a nice good baseline. First meaningful paint. So the first time I see some sort of pixel, it's like 1,300 milliseconds. So 1.3 seconds, and then First to interactive, when actually can click and scroll and stuff like that. So that's 1.9 seconds or 1900. That's Hacker News. So server-side rendered. This is an app, again, I didn't build it, so I'm sure the person who built this could actually do much better if they really focused and got their bundle code split and stuff like that. It didn't look like they actually did a lot of that. So it was kind of slow, again, because of hosting, but it was a 98 for performance, so it was still a great job, server-side rendered. First meaningful paint was 1100 milliseconds, and then the first interactive was 2200. So it took a little longer to actually be able to click the page because you're still waiting for that full downloaded HTML. But still pretty good. Like, if at the end of the day, Hacker News today is totally fine. Like, I wouldn't spend entire sprints on trying to improve its performance unless you had some free sprints to go through. Like, they're still going to be making money on whatever they make. I don't think they make money. It's YCOM. So anyway, they're still getting people to submit to YCOM and submit news, and people are using it. So totally fine. Server-side rendered progressive web app. This one had a little bit of caveat because literally Adi Osmani got into the guy's code and improved it, and he's doing this cool thing with caching. So he's actually caching in local storage the first 10 posts. So they're basically blowing everything out of water because of that. But I wanted to mention that because all the wins they're getting is not from server-side rendering. It's because the guy who works in the Chrome team submitted code to this and made this better by caching. And this is 97. What's a point in performance? It's pretty awesome. Interactive is a little smaller than the last one from Hacker News. Sorry, the server-side rendered from previously. So Hacker News is 1900. This one's 23, and the one previously was 20. Actually, what was it? 22. Oh, so it's actually a little worse. Actually, I don't even know why. I thought I would have an answer for that. And then this is my version, which is about the same about everywhere. First download HTML is actually 1 millisecond because the HTML is already on the CDN. So there's no trip to go to the server to return HTML. So that's the trickery of why it's only 1 millisecond. But you can notice the real difference between it's a time the first meaningful paint and the first interactive. It's almost no time. So we're talking fractions of a second. And I honestly, again, I probably could have did better web packing to make this the first byte to actually work. But again, this was an afternoon for me. So I just kind of stirred up because I wanted for myself to see if my hypothesis of server-side rendering was necessary. And at the end of the day, and again with the second one and all the ones, it really comes down to how well you web pack or how well you bundle your code. Because that's really where it matters. It's not really, it doesn't seem like server-side rendering is anything to really go home and to worry about. I honestly think server-side rendering is a solved problem. So if you want to do it, I think just go ahead and do it. And there's a really cool blog post about async rendering React and using server-side rendering. And he goes through all this stuff of how you can use different plugins and the different ways you can use async, await, and all this other stuff. And at the very end of it, he's just just use this out-of-box solution because this is complicated. And that's at the end of all this, server-side rendering gets really complicated once you have a code base that you want to maintain longer. You have to create React app, did something really awesome where anybody can just jump in the React code and ship it. Server-side rendering makes it so now you have some sort of domain-specific knowledge about your specific app and how you do server-side rendering. So my recommendation is just use Next if you're going to do server-side rendering if you think you really need it all out of the box. Or I would check out serverless side rendering. So I'm going to run through all these things. Server-side rendering has some benefits. It's flexible. It's secure. When your code's actually not sitting next to your front end, it makes it harder because you're going to use something like JWT or JWS to prevent hacks against your server. Also, as far as SEO purposes, everything's rendered at build time. So every time you run npm run build, your content's there. And it's also a faster time to interactive as I shown because HTML is already built for you. So if you do have to hot swap and stuff like that, I'll show you exactly how you can do some trickery to make your app seem like it's server rendered, but it's really serverless side rendering. So what about the things that I actually need a server for? Because you guys are probably thinking, wait, I do this, and I know I can't do this without having server-side rendering. One, you can run stuff at build time, as I mentioned. At Netlify.com, we're doing the thing where we are hosting images locally, but also on Cloudinary. So in production, you will get Cloudinary images that are hosted, that are much faster, and they're basically scalable from the viewport and stuff like that. That's all stuff that we could write code for, but why? Someone's already solved this problem. Let's just use this. And we're doing this on build time using a gulp task. I'm not sure if anybody still uses gulp out there. We happen to still be fans. So we have a gulp task that runs in tangent with our npm run build and our Webpack bundle, and that's what we're doing with this hot swapping. And you can't see it, but in the blue we have a Cloudinary link instead of an actual local /images, or it's actually video, so /video/ whatever. Service workers. So anybody use service workers? Not a lot. Okay. Well, there's good and bad things about service workers. I'd say the bad thing is the offline thing. A lot of people, it's really confusing. There's a really good talk from JSConf.eu where a guy goes through all the pitfalls of service workers, and I would definitely check that out. But offline is not the only thing you can do. You can also do notifications. You can check and set cookies. So if you want to display certain assets or do some user sessions into a cookie, you can do that in a service worker. You can also find and replace content. So Cloudflare is a CDN. They're like maybe one block over. Anybody work at Cloudflare? Good, because I use their service, their cloud worker, which is really a service worker, but they call it a cloud worker, to do the cloud to butt thing. So when you visit the site, I could do this. I could place this on my CDN on Cloudflare and replace all instances of cloud to butt. I ripped it off from the plugin that the cloud to butt. Does anybody remember that from back in the day? Cloud to butt Chrome extension. So anyway, I do that with the service worker. Totally doable. There's some other things you can do with service workers as well. Again, like with caches and stuff like that. Another thing you do with serverless side rendering is outsourcing your complexity. So Cloudinary was an example. Another thing is doing authentication. So with here's a site that I have that I'm working on that I'm using Netlify's authentication. So I can have a user management without having to have a server to manage that user's data. Auth0 is another tool. Again, their one bread and butter is authentication, so they handle that for you. And I'm just outsourcing that complexity. So I don't need to throw up a blog or a marketing site that needs to have login with a server-side rendered whatever. And I get SEO out of the box because I don't have to worry about any of that. Because because of pre-rendering, but if it's just HTML content or static content, it's already there. Like there's nothing to be rendered. It's rendered at build time. And then finally, the serverless thing that always gets conflated with serverless is functions as a service. Has anybody heard that? Lambda. There's also Azure, and there's Google Cloud Functions as well. At ReactConf, there was an example that Sophia Shoemaker did about doing AWS and doing Create React App. Literally, you just click the button. It hits a Lambda function, which is a function that lives on, So it's a function that lives in technically like S3, but it also has an API gateway. So it hits the gateway, and then you can get a function of like JavaScript returns. So you can change these names. Basically, her example was she's changing names, and she's not hitting a server, she's hitting a serverless function that runs on demand. Cool thing about that is you get 1 million requests for free, so you're not paying for a running server just to change a name on a website. Think of like switching out cookies and all that other stuff you can do with Lambda functions, just like you can do with service workers. And yeah, it's pretty awesome. It's free up to 1 million requests, and it's like trivial as far as cost. One other thing that I'm going to run through these last ones. I know I have a lot of slides, but so anybody go to React Rally? Not absolutely nobody. Oh, one person back there. So Netlify had a table at React Rally, and we were giving away a Nintendo Switch if you deployed a site to Netlify. The way we did this, we had a Gatsby template that I already made. You click it, you tweet it, you're in the contest. The problem we had during that whole thing is that this deployed Netlify lives on GitHub, and we're using GitHub repos to deploy sites from Netlify because you hook into Git, whatever. So we did that, and when you don't authenticate with GitHub, you only get 60 requests per hour. So we hit the rate limited based on everybody that was on that conference Wi-Fi really quickly. Like they'd announced that we were doing this. Everybody came to the booth. They figured out what they're doing. They basically locked us out for like 4 hours. So we created a Lambda function to solve this problem. So essentially what you do, you click that little button. We ask, are you logged in? If you're not logged in, we authenticate you with your token. If you are logged in, we authenticate with your token. So if you've logged in with GitHub. If we don't have a token for you, we use ours. But the cool thing about that is we get 5,000 requests instead of 60 per hour. So it just made it a lot easier. So, and we use a Lambda function that's running in the background. And again, we get 1 million requests. We're not paying anything for this. And we're able to do some sort of on-demand like checking for this. And again, Netlify is hosted on Netlify. So we have an API, but we also don't. We're leveraging outsourcing complexity using GitHub's API to do some of this functionality. One more Lambda example. With Netlify, you can host a site, and then you can also add a custom domain and get all that other stuff, SSL. You can do it two ways. You can go do your own DNS, or we'll manage the DNS for you, like we're a DNS provider. So if you click that button right there and you use DNS, what happens is you didn't have to check your DNS and change your name servers to Netlify name servers, but then we can manage all your DNS for you once you do that. So for example, why would you want to do this? So like the React docs hosted on Netlify, there's a branch. So the branch that Dan Abramoff just did, it creates a branch URL so you can preview exactly the content that's changed. That gives you a URL that says like branch.netlify.com. Not as fun because it has Netlify in the middle there, so it's like literally an advertisement. So you could, instead of have like netlify.com, you could change that to reactjs.org, which is their domain. So that way when they do deploy previews, their domain will show up. And they could do that by, it will essentially just look like that. And that's basically the reason why you want to use this feature. The problem is when you submit your domain to Netlify, and you must then point your DNS to Netlify, and then you can do all the features that kind of unlock that for you. The problem is DNS sucks, and it could take up to 24 hours for DNS changes to propagate. And we have no idea when that happens, so we have to create some sort of ping against their DNS until they've switched over to Netlify name servers. So what we did is we created a whole Lambda function that lives inside of our project. And it basically, once you submit to your domain, it triggers Lambda to be able to do that checking for you throughout the day. So if you take up to 24 hours, 40 hours, whatever it is, we'll notify you and say, hey, your DNS is okay. Now you can use all these features. And then now you can use Netlify. So, conclusion, serverless side rendering is worth trying. I'd recommend throwing up Lambda, see if you can do anything that's interesting. If you have a problem or if you have a new site that you want to try, check it out. And also have this question in mind too, do I really need to run a server for this? So if you're doing a side project, I do a lot of side projects, and I kind of forget like what side projects I've deployed to AWS or what I've deployed to Heroku or whatever, and then I don't remember until I get the bill. So like I've literally paid like $50 for a Heroku side project because people found it and decided to use it. And that was like back in the days before they had the $7 plan. So anyway, problematic. I know we all have like dev salaries in SF. I've got a wife and a kid, and I like my money, so I don't want to spend it on random side projects. So use Lambda. Honorable mention, stuff I couldn't fit into this talk. Chromeless.netlify.com. It's built by GraphCool. Anybody heard of GraphCool? These guys built this. They happen to host it on us, so they don't have a custom domain. So it looks like it's us, but it's not. This is a really cool. They're using the Chromeless tool to do a lot of these like server-side rendering things. So they can do. They have this thing called Prep that's built on this that also does what Prerendering.cloud does. But then they could also do this cool thing where you can get like screenshots of different sites. So I don't know. You guys think of a use case for it. But you can go to sites, get screenshots, and render that from Lambda functions. So check that out if you want to. Also, Firebase, they do cloud functions as part of their platform. So you could do like right in line with your data and also with your hosting, because they do hosting as well. You can have cloud functions. So if you want to run Lambdas alongside of your code that's being hosted, check that out as well. And then obviously serverless. If you guys have heard these guys, they are literally building an entire company around the idea of serverless. So check out their examples, because they have more examples than I could actually go through. Also, plug, Jamstack Radio is a podcast I do. You should definitely check it out and spread the jam.